Hi guys, I just wanted to give you a couple of examples on how to do a chi-square analysis by hand. They're actually not that hard to do. I did create you a chart for you guys to kind of track your math in so that it makes the formula maybe a little bit easier to handle. So I do have a couple of examples if you want to print these out. They're available in Canvas so you can kind of follow along with me. It says a developmental psychologist would like to determine whether infants display any color preferences. A stimulus consisting of 4 color patches, red, green, blue, and yellow, is projected onto the ceiling above the crib. Infants are placed in the crib one at a time, and the psychologist records how much time each infant spends looking at each of the 4 colors. The color that receives the most attention during a 100-second test is identified as the preferred color for the infant. The preferred color for a sample of 80 infants are shown in the following table. So 30 preferred red, 13 preferred green, 23 preferred blue, and 14 preferred yellow. So what we're going to do is we're going to go through the steps of a hypothesis test for a chi-square. So the very first thing we're going to do is we're going to talk about our null hypothesis. So I'm going to change my color here. I'm going to write everything in this blue right going on here. So our null hypothesis is going to be there is no preference between the 4 colors. We can also say that P, which is our preference, is equal to 1/4, or if you don't like using a fraction, we can say it's equal to 25%. So basically we're saying that if we look at 100% of the preferences, each one would get 25% of each of the preferences. So the next thing we're going to talk about is our critical value. So in order to do our critical value, the first thing we need is our DF. And remember, our DF for this is going to be our categories, our number of categories, minus 1. As you can see, I don't spell well, so we're going to fix that real quick. So we have 4 categories. Those are our 4 colors, red, green, blue, and yellow. And we're going to subtract 1 from that, and we get that our degree of freedom is 3. The other thing we have to have in order to do this is our alpha. So remember that I didn't say in here, but I'm going to tell you that we're going to use an alpha level of 0.05. And what we're going to do is I've got a copy of our critical regions for the chi-square here. And we're going to go to our DF of 3, go over to where we have our alpha level of 0.5, and we get that our critical value here is 7.81. So we get a critical value of 7.81. Now I want to remind you of what this means, okay? So this means if our chi-square is greater than 7.81, we are going to reject the null hypothesis. But if our chi-square, our x-squared thingy going on here, is less than 7.81, we are, too many points there, we are not going to reject the null. What I need you guys to understand when we're doing null hypothesis testing, and this is true for any of the hypothesis testing that we do, you always reject the null or not reject the null. You never accept the alternative hypothesis. We can only ever reject the null. And we reject the null multiple times, and we say most likely then if we've done multiple studies, then we can say that the alternative hypothesis is true. But we never actually accept that. We always just reject or not reject the null. I'm going to take away this word going here, but we're either going to reject the null if our test statistic is greater than 7.18, which means it lies in this pink region right here, or we're going to not reject it because it's less than 7.8, so it lies in this white region over here of the graph. Okay, so now let's actually figure out our test statistic. Okay, if you'll remember from the previous one, we said that our expected percentage was 25% because we expect it to be even across the board. So I'm just going to fill in that 25% across the board there. And then we're going to get our expected value. So the way we're going to do this is we're going to take the number of samples we had. In this case that was 80, and we're going to multiply that times 0.25. Remember, you have to do it times 0.25 because whenever we talk about decimal or percentages, we always have to change them to a decimal by moving the decimal forward 2 spots. You can also divide by 100. That would also take the 25% and make it into a decimal of 0.25. And when we do that mathematics and we do 80 times 0.25, we get 20. Now, since the expected value for each one of these is the exact same because our percentage is the exact same, every one of these is going to be 20. We expect it to be even across the board, that all infants evenly like them. Okay, so the next thing we're going to do is we are going to subtract. So remember, it's always going to be your observed value minus your expected value. So on this first one, it would be 30 minus 20, which would give us 10. And then on the next one, we would have 13 minus 20, and that is going to give us negative 7. And then here we have 23 minus 20, and so that is going to give us 3. And then 14 minus 20, and that is going to give us negative 6. And now what we're going to do is we're going to take that value right here, that 10, negative 7, and 3, and negative 6, and we are going to square them. So we're going to do 10 squared, which is going to give us 100. Now, when we do this next one, we're doing negative 7, and we're raising it to the second power. Now notice I put that in parentheses, and I did that on purpose because I want you to understand when you're squaring a negative number, it's always going to be positive. So that negative 7 squared is going to be a positive 49. And then we're going to come over here and do the same thing with 3. So 3 squared is going to give us 9. And negative 6 squared is going to give us a positive 36. So now we're going to do our last step. We're going to take this number here, this 100, and we're going to divide it by whatever our expected value was. That's that FE thing again. So right here we're going to do 100, oops, not enough zeros there, divided by 20. So 100 divided by 20 is going to give us, oops, there we go. And then we're going to do 49 divided by 20, and these are going to start giving you some decimals here. So 49 divided by 20, we're going to get 2.45. And then we're going to do 9 divided by 20. Okay, so 9 divided by 20 is going to give us 0.45. And then our last one is going to be 36 divided by 20. That's going to give us 1.8. So now what we're going to do, notice I've got the formula up here, and I should have talked about it earlier, but we're doing the observed value minus the expected value. We're squaring it, and then we're dividing it by that expected value again. And then notice that we've got that E thing, that's that summation. So what we're going to do is we're going to take all these numbers, the 5, the 2.45, the 0.45, and the 1.8, and we're going to add all those together. So when we get our chi-square, it's going to be 5 plus 2.45 plus 0.45 plus 1.8. So if we add all of that together, we get 9.7. So now when we make our decision, so let's come down here, let's talk about making our decision for this problem. So if you'll remember, our critical value from step 2 was 7.81. Okay, so again, if my value for my chi, which is 9.7, is larger than 7.81, which in this case it is, I am going to reject the null hypothesis. This means that there is a preference among the infants when looking at colors, at the 4 colors, because we're looking at just these 4 specific colors. Okay. Horrible speller, guys. Sorry about that. That's why I have spell check. Okay, but again, the reason we're saying we're going to reject the null hypothesis, that there is no preference between them, is because my chi square value, 9.7, is larger than my critical value at 7.81. And as long as this number, 9.7, is larger than my critical value, that is a reject the null hypothesis. So I have another example for you. That one we had even preferences. On this next one, we are not going to have those nice even preferences. So this says a professor in psychology department would like to determine whether there has been a significant change in the grading practices over the year. It was known that the overall grade distribution for the department in 1985 was 14% were A's. Oops, that should say A's right there. Sorry about that. Let me fix it real quick. 26% were B's, 31% were C's, 19% were D's, and 10% was F's. So again, we had 14%, 26%, 31%, 19%, and then 10%. And they have a sample of grades from the last semester, and it produced 30 A's, 62 B's, 64 C's, 32 D's, and 12 F's. Okay, so we want to do our hypothesis here. And again, starting off with our null hypothesis. And we're going to say that the grade distribution has not changed from that of 1985. Okay, so because we don't have even distribution, we can't say that all the grades are evenly distributed. We refer back to the percentages that it gave us for each of those grade distributions. So now let's talk about that critical value real quick. Okay, so again, in order to do this, I need to find my degrees of freedom, which is again my categories minus 1. So since I'm talking about grades, I have 5 categories. So that's going to be 5 minus 1. And again, for this, we're going to go ahead and do an alpha of 0.05. So now let's look and find our critical value. So if we come down here, again, remember we start with our degrees of freedom. Oops, and I didn't even type it out all the way, which is 4. There we go. And we're going to look for our alpha in that. So if we go to 4, come across to 0.05, and we get that our critical value is going to be 9.49. So 9.49. So now remember, if my value that we find in the next step, my chi-square, is greater than 9.49, then we are going to reject the null hypothesis. That means that it's falling in this pink area. So there's my 9.49. Anything above that would be to reject the null hypothesis, meaning that the grade distribution has changed. Anything below 9.49, we would not reject the null hypothesis, meaning that the grade distribution is the same as what it was in 1985. Okay, so again, greater than 9.49 we reject, less than 9.49 we do not reject. All right, so let's go down and let's do our math here. So I'm gonna be fancy and make all this blue real quick. So let's start here. We remember that we had 14% for our expected A's. we had 26% for our expected B's, 31% for our expected C's, 19% for our expected D's, and lastly 10% for our expected F's. Now, it didn't tell us in the problem how many grades it was looking at. So before we start, what I need us to do really quick is add up all of our observed values so we know what our sample size is. So we've got 30 plus 62 plus 64 plus 32 plus 12, and we get that we have 200 observed grades. So that is going to be how we figure out our expected value. So remember, when you do your expected value, it's the sample size, so 200 times the expected frequency, in this case 14%. Let me go ahead and grab my calculator and we'll do this here on the screen. So I'm going to come over here, put my calculator here. So we're going to do 200 times 0.14, and we get 28. So this is going to be equal to 28. And then for the next one, we're going to do 200 times 0.26. And let's see what that is going to give us. So 200 times 0.26 gives us, we expected 52 B's. And then here we've got 200 times 0.31. So let's see what that's going to give us. So 200 times 0.31 gives us an expected 62 C's, and 200 times 0.19 for our D's. So 200 times 0.19, expected 38 D's. And lastly, 200 times 0.10, and we expect there to be 20 F's. Okay, so there's our expected values: 25 A's, 52 B's, 62 C's, 38 D's, and 20 F's. And again, if I add up the 25, 52, 62, 38, and 20, that should get me back to that 200 sample size that I had. Okay, so now we're going to do our subtraction. So we're going to subtract the observed value minus the expected value. So we're going to do 30 minus 25, and that's going to give us 5. And then we're going to do 62 minus 52, and that's going to give us 10. And then we've got 64 minus 62, and that's going to give us 2. And we've got 32 minus 38, and that's going to give us negative 6. And lastly, we have 12 minus 20, and that's going to give us negative 8. And we're going to take each of these values, the 5, 10, 2, negative 6, and negative 8, we're going to square them. So 5 squared is 25, 10 squared is 100, 2 squared is 4, negative 6 squared, remember that's negative 6 times negative 6 is a positive 36, and negative 8 squared, that's negative 8 times negative 8 is a positive 64. Remember, when you're doing these again on this column here where we're squaring it, this should all be positive numbers at this point. Should not have any negatives on this line right here. Alright, so the last thing we're going to do is we're going to take that 25 and we're going to divide it by that expected value. So if we do 25 divided by 25, that's going to give us 1. So we're going to do 100 divided by 52, so 100 divided by 52, and that gives us 1.92, so we're going to round it to 2 decimal places, 1.92. And we're going to do the same thing here. We've got our expected value of 62, so we're going to do 4 divided by 62. It's going to be a pretty small number here, it's not negative, sorry, 0.067. So, no, go back real quick. No, just 0.06. So 0.06. And then we've got 36 divided by 38. So 36 divided by 38. That gives us 0.95. And the last one, we have 64 divided by 20. So 64 divided by 20 gives us 3.2. So here's our 3.2. And then to do our final chi-square, so to do that final x squared here, we're going to take all those values, 1 plus 1.92 plus 0.06 plus 0.95 plus 3.2. We're going to add all of that stuff together and see what that's going to give us. So we have 1 plus 1.92 plus 0.06 plus 0.95 plus 3.2, and we get 7.13. Okay, so now remember from above, we showed that our critical value, was, and I forgot what our critical value is. Let me go grab it real quick. What did we say it was? Yep, 9.49. There we go. So our critical value is 9.49. So in order for, spell that right. There we go. In order for us to reject, our chi had to be greater than 9.49. 7.13 is not greater than 9.49. So in this particular instance, because 7.13 is smaller than 9.49, we do not reject the null. Okay, so we're going to keep that null hypothesis, which means, remember, this is what we're talking about, which means that the grade distribution for the psychology is the same as it was in 1985. Okay, so again, rejecting the critical only if, or rejecting the null hypothesis only if my statistical value that I found, that's chi-square in this instance, is greater than my critical value. So again, 9.49 is not bigger than, or excuse me, 7.13 is not bigger than 9.49, so I cannot reject my null hypothesis. So I do not reject, means that they're still assuming that the grade distribution is the same as what it was in 1985. If you'd like to see another example of how to do a chi-square by hand, just let me know and I can do another video. But hopefully this helps. Hopefully doing the chart like this helps. I really would like for you guys to make sure you understand what I did in this chart. Hint, hint, this is probably going to be on your test next week. Again, let me know if you have any questions.